Have you ever tried to spot a fly buzzing around a far-off lighthouse? Well, probably not, but astronomers have done something just as impressive, finding planets around other stars. A common way to discover these planets is to let them block out some of the star's light, like you just saw. If you didn't see the difference, that's okay, because this is why these planets are hard to detect. They're so tiny compared to stars. To complicate things further, stars are like teenagers. They rarely show their true selves. It's nearly impossible to know what causes a star to change its brightness. But fear not, because astronomers have other means to hunt for these planets: gravity, light, and very sensitive telescopes. You may have heard that planets orbit stars, but this isn't exactly true. Instead, stars and planets move along a sort of cosmic merry-go-round where stars are extremely close to the center and planets are further away. Because of this, stars wobble slightly when there's a planet orbiting them. Unfortunately, this wobble is too small to see directly, but astronomers have found ways to observe this wobble indirectly, and it's all thanks to the Doppler effect. What is the Doppler effect, you ask? Let me show you in the world's most mismatched boat race. As you can see, the moving boat makes waves that bunch up in front of it and spread out behind it. The waves from the stationary boat are evenly spaced since it's not moving. This happens for light waves too, and this is exactly what helps us detect planets that orbit other stars. When a star is pulled towards Earth by a planet orbiting it, the star appears slightly bluer since bluer light has shorter wavelengths. And when you find a star whose blueness changes, you'll know it's wobbling. Combine this with the star dimming slightly, and you've found yourself a planet. Maybe. Lots of things can masquerade as planets: failed stars, clouds of dust, and even other stars. But there's one key way to tell planets apart. They're so tiny compared to stars. The more a star changes colors, the more massive the object orbiting it is. So if the star only changes colors slightly, you know you found a planet. You even know the planet's mass.
And there's more we can discover about these far-off planets. Using only what you've learned so far, you can figure out the size of these fly-sized worlds. When a fly buzzes in front of a lighthouse, you don't see the lighthouse dim. But when a person passes in front of the lighthouse, you see the lighthouse darken. The same principle is used to find out how large faraway planets are. The larger the planet is, the more the star dims.
But why does it matter if we find these planets? Because finding these planets puts our imagination to the test. We found planets that are made of pure diamond, ones that rain molten iron, and maybe some that even harbor life. Who knows, maybe you'll find one.